Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Linode. With their new managed database service, you can launch a production-ready MySQL, Postgres, or MongoDB cluster in minutes, with automated backups, 40 gigabit connections from your application hosts, and high-throughput SSDs. Go to dataengineeringpodcast.com/Linode today and get a $100 credit to launch a database, create a Kubernetes cluster, or take advantage of all of their other services. And don't forget to thank them for their continued support of this show. Your host is Tobias Macey, and today I'm welcoming back Nick Schrock to talk about software-defined assets and his work at Elemental on Dagster to improve the developer experience for data orchestration. So, Nick, can you introduce yourself for folks who haven't heard of you before?
Yeah, thanks for having me, Tobias, and thanks for that intro. As you said, my name is Nick Schrock. I'm the CEO and founder of Elemental, which is the company behind Dagster. Before Elemental, my career was mostly spent at Facebook from 2009 to 2017. And there I founded this team called Product Infrastructure, which was to make our application developers more efficient and productive. And kind of the most notable piece of work that came out of that was that I was personally involved in was GraphQL, and I'm one of the co-creators of that. And then moved on from Facebook 2017 and got into this entire domain and started working on data orchestration.
And in terms of the overall Dagster project, for folks who want to understand more about what it is and some of the history, I'll point them to some of the other interviews that we've done. But the last time we spoke was last November, and I'm wondering if you can just give a quick update on what's new in Dagster and its reaction to the evolution of the data space since the last time we spoke.
Yeah, so since November, we've been making a ton of progress. So in December, the month after that interview, we launched our cloud product to early access. And that's been going better than I anticipated, actually. And we have tons of users across all sorts of companies, all the way from startups to Fortune 500 companies. And as we'll talk about later in the episode, we're actually going to be launching that to general availability to the open public next month on August 9th. So that's super exciting. In terms of the open source project, we had talked about it on that podcast, but we've really been doubling down on this software-defined assets direction. And in November, it was a super early prototype. Well, not super early. It was a fairly early prototype being used by a few early design partners. And now, adoption and development has accelerated massively. And we've launched it with a stable API. And then we're actually also launching Dagster 1.0 next month at Dagster Day, along with our Cloud GA launch. So it's been a huge 6 months for us.
And so in terms of the overall software-defined asset concept and some of the ways that it manifests, I'm wondering if you can talk to a bit of what the motivation is and what the meaningful impact is for data teams who are working with software-defined assets as their primary abstraction, rather than the core abstraction of this task-based DAG that folks have become familiar with since the early days of data orchestration, and especially exemplified by the Airflow community.
Yeah, so in terms of the motivation, what we saw, and this was last summer when we really started to dig into this, is that a task-based orchestration system was increasingly out of step with the way that data teams wanted to approach their data platforms overall, and also the way that all the constituent tools in modern data, I'll avoid the term modern data stack, which were very kind of asset-oriented or model-oriented. So if you go to Airbyte, that'll talk about sources, right? And they model a distinct set of sources in their system, or Fivetran similarly. If you go to DBT, they'll be modeling the system in terms of DBT models and not tasks. And what was interesting, and this kind of came out in this, discussion around bundling and unbundling platforms, which happened in the spring, but effectively tons of the information that used to be in the task-based orchestration layer were pushed down into these constituent tools. Whereas, for example, prior to, say, DBT, each table would have had a corresponding task in Airflow, say. But now, if you're just invoking DBT Cloud or DBT Run, that entire DAG is represented by a single task in the orchestration layer. And therefore, the orchestration layer is not nearly as useful in terms of providing a single place where you can have visibility into your entire data platform. So we saw that happening where task-based orchestration no longer mapped to the constituent tools as much. And then second of all, just in terms of even absent those external vendors, the platforms were becoming more and more complicated and people wanted a more declarative approach where they could manage more complexity in their head. And the kind of more declarative approach of software-defined assets really resonated with us and our early users. And that was kind of the motivation that happened there.
And in terms of that early experience of releasing this capability, digging into that particular approach and some of the ways that that mapped to different teams' mental models, I'm wondering what were some of the notable outcomes as far as the development approach that teams had to building their data systems and data products and how that factored into their overall practices of how they thought about what the output of their work actually was.
Yeah, that's a great question. So in terms of outcomes here, I think, first of all, the practitioners who are working in Python and orchestrating all these systems and building data assets in Python, they just became more productive using the system. They have to keep less stuff in their head. They no longer have to write one centralized DAG artifact or flow artifact manually. So if you come from Airflow, there's typically this DAG construction file, which ends up being a sort of centralized, unowned dumping ground of code that gets more complex as your data platform gets more complex. And with software-defined assets, you no longer have that centralized artifact. The complexity is distributed across the entire system in a good way, meaning that that centralized DAG is constructed for you. So it just makes it so that coding is faster, collaboration is easier, and it's an overall win. I think more profoundly, what we found, and this is also based on some early feedback too, is that this allowed users who want to, say, develop their entire data platform across a bunch of different independent GitHub repos by independent teams. They can each individually code in their own world. Once deployed, they can actually interconnect all the assets that are built in those different constituent GitHub repos. So it's really been a way to unify the different practitioners who might be working quite independently, but are still building up to one cohesive data platform. And then that's kind of connected to the last bit, which is now they finally have a place to go to where they can understand how all their data products interrelate. So they no longer have to go into different constituent tools and kind of like have it all in their heads. There's just like one spot where everything is defined. It's been pretty interesting to see how that's developed. Like one anecdote I really like is that we had an early cloud customer who started to adopt software-defined assets, and they kind of started with our out-of-the-box integration. So they used the ingest tool, they used some custom Python scripts, and they integrated that in the software-defined assets, and then they also imported their DBT graph. And they saw this interconnected web of assets, but then they also use a feature store called Feast. And it kind of was in its own world because they hadn't ported that to software-defined assets, and we didn't have an out-of-the-box integration for that. So they actually built their own integration to bring Feast into software-defined assets land. And I thought that was interesting. One, it was just like the value of it compelled them to write that integration. And second of all, it actually interconnected the data engineering and ML sides of the house into one cohesive lineage graph. And I think that's a lot of the promise here, is that you no longer have to de-silo your organization, right? You can kind of conform everyone to this common standard and have your entire org, regardless of persona, kind of interconnected in this single fabric of assets.
And to that point of building their own integration to be able to represent what was happening in Feast as a software-defined asset, can you talk a bit more about what is actually involved in building that type of an integration and what it means to actually represent some of these external systems through this asset-oriented abstraction?
I mean, in the end, if you look at the Python code, that's a software-defined asset. It's just a function. So it's not this huge lift to do an integration. It's just merely annotating your existing, because all these systems generally have Python integrations, right? So in the end, you're writing some Python code, which invokes the tool that you want to invoke. The magic is sort of how we structure the software and structure the metadata. So it just means that you've written an integration, it ends up being a Python function which invokes something else, but then you can plug into our system to interconnect it to the other assets. And that's kind of the critical piece here.
And as you went through that early phase of proving out the idea, testing it out with your early adopters, and then iterating on that with some of the subsequent releases, I know that you have stabilized the API. And I'm wondering, what were some of the shifts in the interfaces and the abstractions and paradigms you wanted to expose for people to be able to work in this mode of the software-defined asset? And what were some of the modifications that were necessary internally to Dagster in the framework to be able to support that as a first-class capability?
So I'll start with the first one, which is what are the changes we had to make to core Dagster in order to do this? And the answer is that the core was relatively stable, right? So software-defined assets is just a layer on top of our existing core, right? So at its core, a software-defined asset refers to an op, which is our core unit of computation, kind of the foundation of our task-based orchestration layer. If you write an asset, it builds the centralized DAG artifact, the job, for you. And it also manages interactions at a fine-grained level with our asset catalog, which also predated software-defined assets. So it's actually this relatively thin layer of software on top of the existing capabilities in our core system. And that's important as well, because our task-based orchestrator is not going away, that core orchestration engine. Some tasks, not to double use the word, some activities in data platforms are still highly amenable to kind of more imperative programming models. And those are critical to support, and we will always support that. And in fact, the software-defined asset layer needs that layer in order to execute well. You can kind of like think of it, it's not a perfect analogy, but in that way, Spark, for example, is evolving so that more and more of its computations are encoded in SQL. And maybe in the long-term Spark, 80% of the computations will be in Spark SQL. But there's still going to be this critical 20% that are encoded in data frames. It's more imperative, but you need to do it in order to accomplish a lot of the activities you want to do. And we kind of view software-defined assets in our task-based system in a similar sort of way, where we anticipate over time more and more of the activity in the system will be encoded in terms of the software-defined assets API, but there's still going to be absolutely critical activities that you need to use this lower level for. So that all being said, software-defined assets is a layer on top of our op layer. And that will forever and always be true. So most of the work was actually more about kind of conceptual work and getting that layer absolutely right. And then building tooling on top of it, which was by far where the lion's share of the effort was. So that's one thing in terms of your question about changes to the interfaces and internals of the system. Your other question was, how do we respond to feedback and how the API shift? And I think that focused on maybe three different things. And one was a lot of the users who understood this very intuitively and wanted it were our modern data stack users that were heavy dbt users and wanted much more advanced orchestration capabilities on top of dbt. So tons of features there. In particular, I thought one was interesting, which speaks to what I was talking about before, was we had this ability initially where you could write in the same GitHub repo, be able to load dbt projects and orchestrate it right there. But what tons of teams wanted actually was the ability to have their analytics engineering team to actually have a more independent GitHub repo in their own development cycle, and then have the orchestrator actually consume the dbt manifest file, for example. And that required some changes on our end, but it spoke to that people are really thinking about the interfaces between teams in these systems, and then how to make it so that, yes, they can deploy and operate independently, but once deployed to prod, the orchestrator kind of stitches the entire thing together. So we got a lot of feedback around how our dbt integration worked, and then how that kind of and then I also viewed it as feedback about how people want to organize their teams. And that was super interesting. On a more tactical level, We were originally going to de-emphasize our config system a little bit in the software-defined assets layer, which is effectively the ability to parameterize computations without changing code. But super early on, people were like, wait, I want this. I missed this capability in the old system. So we actually had to re-front load that quite a bit. And then lastly, we knew it was going to be a demand, but immediately people wanted to focus on interoperability. So they have their existing task graphs. Some stuff are appropriate to model as task graphs. How do you want to interleave those layers? So I think those were kind of the early themes and feedback which we responded to. But the core conceptual underpinnings of the project have remained quite constant from the beginning.
As you have gone through this process of working through the software-defined assets capability, updating the interfaces and APIs and some of the tooling and just general messaging around that functionality. In parallel, you've also been going through a journey of the early beta testing and early adoption of your cloud product. And I'm curious how that journey has paralleled the capabilities of software-defined assets and some of the ways that those two areas of effort have played off of each other in terms of your own internal engineering work.
Yeah, that's a good question. I think the easiest answer and why I'm so excited about the cloud product happening is that the ability to have a hosted service allows you to deploy new capabilities and bug fixes and new system infrastructure to your users in a completely permissionless way. And that allows you to iterate with your users far more quickly. In a pure open source model, let's say you fix a bug or have a new feature in your UI, you push it up to PyPy, and then you're kind of waiting for people to upgrade, and that's their own, and then you're subject to their own internal infrastructure release processes and whatnot. And with cloud, we can push whenever we want, get new capabilities into users' hands extremely quickly, and have a much tighter feedback loop with them. And that's been able to accelerate our product development dramatically. And I'm super excited to be able to do that at scale.
So you've been going through this process of adding this software-defined assets capability, cementing that API. Just prior to that, you went through the work of updating the core abstractions for Dagster from these nomenclatures of solids and pipelines and
Tobias, you're going to bring those up?
and that whole work, and then streamlining that into this jobs ops graphs paradigm. So you've gone through a number of iterations. There's been a whole host of work. You've seen a lot of adoption. And so that leads us to what you mentioned earlier. On August 9th, you're having this Dagster Day event where you're going to be committing to a 1.0 stable version of Dagster. You're going to be releasing the cloud product as GA. I'm wondering, what are the major lessons that you and your team have learned in the process of going through the initial development, the initial adoption cycles, figuring out what are the concepts that actually make sense in this space, exploring how you can keep up with the rapid pace of evolution in the data ecosystem writ large, while staying true to the core ideas and abstractions that you're putting into Dagster, and just some of the commitments and what it is about where you are in your journey right now that makes you feel confident in committing to that stable version identifier.
One of the big takeaways here is don't be too cute with your naming. The name Solid was my fault. It was actually originally going to be the name of the project itself, and I kind of liked the name, and then anyway, we don't need to belabor that one. So don't be too cute. Name things in the most obvious way possible. It was a critical thing for us to switch to a more natural nomenclature and fix some very core API problems with that original pipeline Solid. There were other things called modes and presets and all sorts of stuff. And we wanted to simplify and consolidate that into a far more elegant API. And that was a huge step forward for the system. And then assets were always going to be a layer on top of that. So really the foundation of the 1.0 release and the big breaking change we needed to make was switching to this op job graph model. And that is the stable core foundation that we're building everything on top of. The feedback on those APIs has been extremely positive. All of our major users have migrated everything. We're super confident in those APIs, that core stable foundation. And it was really that laid the foundation for this 1.0 release. And that doesn't mean we're going to be stopping development by any sort of means, but any further changes are going to be additive, and we will commit to supporting these APIs for the long term. I guess, can you remind me the other subcomponents of the question? There was a bunch in there.
The main driving point of the question was why you're confident with committing to this 1.0 version specifier, but also just some of the overall sort of lessons that you've learned as far as how to keep up with the rapid pace of change in the data ecosystem, and what are the core ideas and lessons that you've been able to lean on that have stayed true regardless of the external turbulence that is a constant in this space.
The word that you used, I think, is telling, which is turbulence. I think there's two things going on here. There's what are the fundamental things we are trying to accomplish in our jobs? And regardless of all the different noise in the ecosystem, that doesn't change that frequently. And at the end of the day, we're writing code to produce assets and whatnot. There is tons of activity in the tooling ecosystem to optimize different parts of that workflow and make certain parts easier and improve ergonomics and whatnot. So, the 1.0 signifier is mostly around our core abstractions, and then there's the entire integration layer and all the different libraries that both we and our community maintain. And that's kind of where you are dealing with the turbulence, so to speak. And as to new tools come and go, the core notions in our framework will remain the same.
Along with the GA release of Cloud, what are some of the new capabilities that you're planning on releasing as part of that?
So there's a ton of new stuff that we're going to be rolling out. But, one thing I'm incredibly excited about in our GA release that's coming out. Well, first of all, for Dagster 1.0, there's no huge changes coming out with Dagster 1.0, right? The whole point is that there's a stable set of features that we are marking as mature, and you can be confident that things aren't going to change in that stable core going forward. The Cloud GA release is a bit different. And first of all, what is the Cloud product? And it's a managed orchestration service so that you can write your code and we host your control plane. So you can deploy Dagster effortlessly in an enterprise-grade way, and it comes with features like, role-based access control, authentication, and you can just focus on your business logic. A new capability that's coming out that I'm incredibly excited about, which I think solves the sort of unsolved problem in data engineering and data management, is what we call branch deployments. So there's this current problem in, I think, all the orchestrators, which is you can spend a bunch of effort structuring your code so that it's locally testable. And so you have a fast development lifecycle. And that's only in certain of the frameworks. Airflow doesn't really support local development at all. And then what teams are left to do in those cases, well, let me step back. So let's imagine you do a bunch of work and you're mocking out your data warehouses and doing all this work to try and make it so you have a nice local development flow on your laptop. There's a problem there, which is one, there's a ton of stuff that still isn't tested if you aren't interacting with the services you're actually going to interact with. And then if you try to interact with those services from your laptop, a lot of time your security policies prevent you from interacting with that. And then what people are left to do is still to do a bunch of testing in a staging environment. But those centralized staging environments are also a pain in the butt to manage. And often if you have multiple developers deploying code to that staging environment, they're overriding each other's changes and it just gets complicated and whatnot. So you either have these clumsy to use, clumsy to manage staging environments, or what people all too often do is just end up testing in production. They just push their code and then they manually trigger a job or a DAG and just see if it seems to work. And it's this incredibly low productivity lifecycle. What branch deployments allow you to do is that when you're using Cloud, is that for every PR that you make, it actually creates a lightweight staging environment that's specific for that PR. So you write your code, you branch, you push, then our infrastructure takes over, deploys your container, and then actually spins up a lightweight environment where you can either automatically launch a job on every push or manually do it in our UI. And it provides this sort of very lightweight staging environment that serves almost as like an IDE because you can like click runs and see if they complete or not. It's a complete game changer in terms of the development lifecycle. And it just fits so naturally into the development workflow. And it's just this incredibly powerful capability. So I'm incredibly excited about that.
It's time to make sense of today's data tooling ecosystem. Go to dataengineeringpodcast.com/rudder to get a guide that will help you build a practical data stack for every phase of your company's journey to data maturity. The guide includes architectures and tactical advice to help you progress through 4 stages: starter, growth, machine learning, and real time. Go to dataengineeringpodcast.com/rudder today to drop the modern data stack and use a practical data engineering framework. And to your point of the staging experience, being able to make data workflows and data orchestration something that is tenable for having a fast feedback loop for the development workflow, it's definitely great having that capability built into the orchestrator, but then there's also the question about what about all the pieces that orchestrator is connecting to? How do you manage those branches and preventing accidentally polluting the actual production data or the production systems, and just the overall space of developer tooling, CI/CD, just making sure that you have those fast feedback cycles and are able to validate your logic and your end-to-end workflow in the data space is still very painful. And I'm wondering what you see as some of the other sharp edges that folks are going to have to deal with now that they do have this capability of being able to easily branch their orchestration layer, and just how to think about what the broader impact is on the rest of their systems with that capability.
It's a great question, Tobias. And we are able to use the orchestrator itself to manage all these different test environments. So let me give you a simple example. Snowflake actually has good support for this. They have a feature where you can clone a schema, which effectively makes a lightweight copy of your data in a copy on write way, but it does it safely. So if you do any sort of mutation, it does not affect the source production data. This lends itself very nicely to this branch deployment model because effectively you make a clone schema for every branched environment. You can't actually pollute the production data, but you have access to it in order to test your flows. And then if you actually do any writes into that data warehouse, it still is safe, right? What's awesome about branch deployments is that you can set it up so that you can automatically run a job whenever you push up new code. So the way it works is that you actually have a job in Dagster that clones the Snowflake schema. And every time you push up a new PR or a new change within that PR, it re-clones the schema every time. So you kind of start from fresh. So by marrying the ability to have underlying infrastructure kind of support these things, and have the orchestrator be able to orchestrate the management of those test environments, it kind of all comes together in one nice package. Now, the different vendors and tools support those type of things to different degrees, right? So Snowflake has kind of the nice version. If you had like a full unmanaged data lake, you might actually have to kick off a job that copies a bunch of data, right? Or write what we call a custom IO manager that would know how to read from kind of the source tables and then write out to copies elsewhere. So depending on the tool support and whatnot, it depends on how much work you have to do. But the entire idea is that by having this capability built into the orchestration layer itself can manage all these test environments. And that's really where this magic comes together.
For the data lake use case, also, there are things like LakeFS that allow you to have a sort of branch and merge style workflow for your data in S3. I know Iceberg and Project Nessie are looking to be able to do that in the space of things like Hive tables or tables in your, Amazon Athena Lake or things like that. And now that there is more movement in some of these different vendors and in what you're providing with the branch deployments, and it is a conversation that is being had, I'm curious what you see as some of the potential next steps that we as a community can and should take to help keep that ball moving or keep that flywheel spinning and continue on improvements in being able to actually manage these complex and heavyweight workflows while being able to safely iterate quickly on updating logic, modifying schemas, figuring out how these data flows actually impact the business, and just the end-to-end workflow of being able to manage these high value, high risk, heavyweight tasks.
This is one of the reasons why I'm so excited about an orchestrator finally supporting this type of thing, is that I think it will provide a great incentive structure so that people are forced to make progress more quickly. Because what will happen will be something like this, where people are orchestrating two different technologies, and one of them, like Snowflake, has a super easy, or LakeFS has like a very straightforward way of doing this. And then they're trying to orchestrate it with a tool that doesn't. And then they'll immediately be like, wait, like they have this workflow ready to go, and it's just one tool that's preventing it. And then those users will exert pressure on their vendors and tools in order to support that better. So yeah, I'm just super excited about having a place where there's an end-to-end workflow that kind of aligns with this trend that you're seeing, so that it makes it clear what tools have fallen short here, so to speak. And I think it will provide a nice incentive structure for everyone to get their ducks in a row. Because right now, if you're trying to orchestrate all these different capabilities, right, LakeFS and Snowflake's clone schema, or copying whatever and doing all their different bespoke branch and merge workflows, it's so much work to construct that end that no one does it. And therefore, people don't even know what they're missing yet. So to me, the way to really make progress on these type of issues is not to like gather a conference together and like convince every single vendor and like nag them to do this and this and this. It's just like with actual tooling, with actual users and actual incentives, just move everything much more quickly.
I agree that having that capability of managing the full kind of test environment in the core of your data platform is definitely going to be a massive leap forward in terms of people's experience, and even thinking about that as being a possibility, because as you said, otherwise it's this very heavyweight exercise that is full of toil of just saying, okay, how do I automate each of these pieces individually and be able to manage all the infrastructure and manage all of the logic and hopefully not shoot myself in both feet by accident in the process.
Yeah, totally.
And going back to this release of the 1.0 version of Dagster, the GA release of the cloud product with these new capabilities, as you said, you've got this Dagster Day event that you're planning to make all of these announcements. I'm wondering, what are some of the other things that you have planned as part of that event, and what you're hoping the participants will take away from it?
The event is, short but sweet, where I think we're going to, clock in, 45 minutes-ish or so. And so what we really want to be is like a very information dense, high signal to noise ratio, where you can come understand the entire value proposition of the platform end to end, all the way from the framework to the cloud product, and then have a forum where you can connect with other community members and ask questions, and in general be kind of the first to know what's going on with all this stuff. And it'll be available afterwards, of course, to view. But we're really excited. This it really is this coming of age moment for the platform, where we're powering with cloud and open source like some of the most sophisticated data and ML platforms in the world. People have bet their entire mission critical workflows and their entire data platforms on this technology. And this is more kind of a coming of age party that communicates that underlying reality accurately, and then opens up this capability to the entire world. So, it's a big day for us.
One of the interesting aspects of marking something as stable with that 1.0 version is that it opens the doors for a lot of folks to even consider using it in the first place, because there are organizations that have restrictions that say we will never actually use something until it hits version 1.0, or there are people who aren't comfortable being the guinea pigs or testing things out with the possibility of breaking changes because they don't want to put in the time to actually stay up to date with things as they evolve. I'm curious what you anticipate as the overall impact on the size and composition of the community around Dagster now that you are hitting this stable milestone, and some of the things that you as an organization and managers of the community are doing to prepare for these new categories of users that are likely to start kicking the tires on Dagster?
Like you said, there's a whole set of users out there who it's extremely important for them to have the company and the project signal to them that they're not going to be broken and it's a stable foundation to be built on. And the reality is we've been operating like a 1.0 project for a long time now, both in terms of the reliability that we provide to our users, as well as like effectively the job. The core task-based layer, for example, has been stable for a long, long time, and we don't break anyone there. So on an operational basis, day to day, not that much is going to change for us, actually. We've been like operating like this for a while. We have done renewed focus on our documentation. We have a full-time technical writing staff now. They're doing fantastic work to improve the docs. So we're preparing to scale our product education and community management alongside this.
Now that you do have this stable point, this marker of a next stage in your life cycle, what are some of the new and upcoming capabilities that you're starting to look to with this solid platform to be able to build from?
We are going to continuing to invest, in additional integrations and additional tooling on top of the software-defined assets, stuff in particular. And I think that, you can think of the system as layered, right? So when you have a core stable foundation, then your activities generally end up being focused at the tooling built on top of that. And that's really where a bunch of our focus is going to be, as well as on integrations. I think there is just a ton of work in terms of both integrating both at the software-defined assets level, but also working with partners to make those tools work with branch deployments, for example. And I don't think we can underestimate how much both work that is and how much value there is in there. So I think you'll see us focus a ton on integrations work and value-added tooling over that stable core. In terms of other directions, on the commercial side, you'll see us also working on supporting organizations as they scale across our platform, whether that means more advanced role-based assets, RBAC capabilities, the ability to track lineage across your entire org as you cross deployments in the Dagster platform. But we are super focused on getting 1.0 and the GA product out the door. And, we'll be publishing more of a roadmap after that.
One of our earlier episodes, we had a good conversation about your opinions and framework for deciding what capabilities belong in the open source framework capabilities of Dagster and which features belong in the commercial cloud offering. And I'm wondering how this stable marker of the platform and of the cloud system and its release into general availability is going to factor into your ongoing commitment to or modification of that philosophy, and just some of the ways that you're continuing to manage that tension of which capabilities need to be paid for the sustainability of the organization and which capabilities need to be part of the open source because they are necessary for the continued viability of Dagster as its own project.
First of all, let's step back and talk about how to even approach this issue here. The goal of Dagster has become as broadly as an adopted standard as possible for structuring your data platforms and data assets. And then Dagster Cloud is to build, an awesome managed surface that is structured on top of that standard. And in terms of what goes into that standard, the open source versus what goes into the proprietary platform, I kind of divide the world into three layers of complexity here: application complexity, operational, and enterprise. So application complexity is about how developers work with the framework to structure their code in order to have better API ergonomics, testability, all that stuff. And that's effectively the relationship between the engineer, developer, practitioner, and the code that runs in their process, right? Literally, they are pip installing something and they are running Python code that we have authored that calls into their code. So on a very practical level, that needs to be open source because you have code in the same stack trace and there's no process boundary and all that stuff. And also, we want that framework to be composable and embeddable in all sorts of interesting contexts because we can't predict how everything's going to be used. And that's like the fun and the joy of open source. So that's one layer, the application complexity and the open source framework. That will forever and always be open source. Then you get into the land of like tooling built on top of that stuff, right? And I think that's where this gets more subtle and interesting. So we want teams to be able to self-host open source Dagster and run production workloads on it. And we want them to be able to run that on different infrastructure like ECS or Kubernetes or just an EC2 node or whatnot. We want people to be able to do that. We want them to be able to self-host that, and we will always support that. But we also have Dagster Cloud, which is a managed service which hosts the computations on their behalf. And the way that I kind of divide the world here in terms of what should be proprietary and what should not be is actually a lot of it is in terms of execution efficiency of the organization. Meaning it is much easier for us to develop advanced operational capabilities on a centralized hosted platform. We can deploy it whenever we want. We can fix bugs immediately and so on and so forth. Let me give you a very specific example. Like a database migration, it is like so much easier for every single stakeholder involved if we run one centralized database migration instead of forcing our thousands of open source users to run their own database migration against their own infrastructure. Doesn't mean we're never going to implement anything that requires a database migration. It just is an example of if we can centrally manage something, we can move faster and we don't have infinite engineering resources. And then we can fix bugs on the user's behalf and whatnot. So I often think of this in terms of if there are operational capabilities where we can centrally host it and there are massive economies of scale for one organization to do it, instead of distributing that work across thousands of organizations, we should really bias at minimum towards initial development being in the proprietary domain because we can move faster and provide better quality of service. I think the value exchange here, and this is something we're rolling out with GA, is that there should be a fair usage-based pricing model where small players can participate as well as the largest enterprises. So just to give another example of like where economies of scale don't apply, we have a Kubernetes executor. It's not like we're going to withhold a bug fix from that and only apply that to the proprietary stack. First of all, it's just the wrong thing to do and goes against our values. But in the rubric that I just laid out, there's no economies of scale to not fixing that more broadly, right? It just is better for everyone. And then the last layer of complexity is enterprise complexity. So security, auditing, et cetera. These are capabilities which are complicated to implement that we want to be able to push changes instantaneously and fix any issues there. And that enterprises who want those capabilities typically want a paid relationship anyway. Like they want to write a check because then there's someone on the hook when something goes wrong. So again, that was kind of a long-winded answer, but 3 layers, application complexity, that's really the relationship with the individual practitioner. Those capabilities will always be open source. Managing operational complexity, we want to support production workloads, but for really complicated capabilities that take a lot of work to host and fix and all that, we want to bias towards centrally hosting those. And then lastly, enterprise complexity, which is strictly in the province of the proprietary domain.
Digging into that middle layer of the operational complexity where there is this decision to be made about whether it is proprietary or open source, you mentioned that at least the initial development for some of these capabilities belongs in the commercial offering. And I'm wondering what your decision structure or mechanisms are around being able to say, okay, we've built this internally, but this is actually something that is useful in the open source. And so being able to do that initial development, offering it as a paid capability for your cloud customers, and then eventually migrating that into the open source, and just how that decision structure and how that actual management of the code and being able to make it something that can be migrated plays out in your mind.
Yeah, we don't have a specific process in place yet. I guess what I'll say is that a lot of it just kind of happens because the proprietary service is really kind of a shell where work that's done on it naturally flows down into our core infrastructure. So that kind of just happens for free. And in terms of like an ongoing process where we develop things that are focused on the proprietary platform and then push them downstream, like there's no formal process in place in there. We've been so focused on getting this GA broadly applied, that hasn't been a focus.
In your experience of rolling out the software-defined assets capability and onboarding some of your early customers to the cloud platform, what are some of the most interesting or innovative or unexpected ways that you've seen those capabilities used?
Couple examples come to mind. A bunch of our cloud users are actually energy companies that you probably have heard of. And one of them has really integrated Dagster into their geologists' workflow as they are doing analysis, to the point where it's actually completely integrated with their own internal custom apps. So they have internal apps where they click a button and it actually kicks off Dagster Cloud runs. That metadata is then fed back in to their own custom proprietary app. It's almost kind of like their custom operational tools and our tooling has almost like fused into one centralized system, which is super cool to see. It's just like, it demonstrates the value of like using open source standards like GraphQL to model your web app, because then someone can literally effectively build a lot of those capabilities in different contexts and integrate it in interesting ways. So that's been super interesting to see. Unexpected. This is one of my favorites. One of our customers is KIPP, the Knowledge is Power program, which is a charter school program. And they actually, or a couple of their geographies, they have a fairly fragmented organization, are actually using Dagster to, in effect, build report cards and progress reports for their students, which sounds wild, but it makes sense if you think about that. They actually use a bunch of different SaaS tools to track student activity, to record their work, to do attendance, all sorts of stuff. And then they actually built a data platform in order to assemble those tools and integrate the data and then produce a cohesive report that can be viewed by parents and students. So, I love it because I can explain this to like my mother. It's like, okay, imagine you have this report card. That is in effect a data asset in this system, which is composed of other data assets and has been integrated and computed upon. And in the end, there are data pipelines which produce these data assets for parents and teachers. And it's a very like graspable example that people can understand. And something I did not anticipate that Dagster would be used as an orchestration platform for student report cards, but here we are.
It's all data. It's all information that has to go somewhere.
That's right.
In your experience of bringing Dagster and Elemental up to this point of having a stable, solid foundation to build from and marking it with this 1.0 release and the general availability of the cloud product and all of the new capabilities and features that you have planned subsequent to that, what are some of the most interesting or unexpected or challenging lessons that you've learned in that process?
It does speak to the 1.0 release. And it's something I understood intellectually before, but now really felt in my bones. It's just how important it is to communicate clear expectations around stability and future changes and make sure to do enough upfront design in order to do that effectively. I think early in the project, we were a little fast and loose about we want to be able to move quickly and whatnot, but it's very different. You can change UIs quickly, and that's fine because you're not breaking people's code, but you just have to have a very different standard, in terms of communicating that this is a stable foundation to build on and that you have to do more upfront deliberate design, especially in these. Yeah. So I think that's been a lesson and have had to learn that. And, we've learned from that and have changed our processes. And now we're signaling this new phase. And the other thing, and I spoke to it earlier, is again, I knew it intellectually, but it just in the last 6 months, it has just become super, super real. Is that, we're excited about cloud. Like, obviously, we're excited to build a sustainable business model and make forward progress on that front so we become a sustainable organization. But cloud has also just increased our pace of product velocity because we have a tighter relationship with those customers. We can see the effects of our changes immediately. We can push them changes. They can provide feedback. In a day, we can fix a bug or add a feature. And it's just like this super exciting new phase of development. So those are kind of the two things that come to mind.
So we've spent the past hour or so extolling all of the virtues of Dagster and the new capabilities and benefits that you're providing. But what are the cases where Dagster and or Dagster Cloud are actually the wrong choice and somebody is better suited with a different orchestration system or just writing a bunch of bash scripts or just using the built-in orchestrator for their point solution tool?
Yeah. So to the last thing is that if you are only using that one tool and as a built-in orchestrator, just use that one tool. I think that's, fairly clear. And you only need like cron-based scheduling, for example. But broadly, I do think that orchestration is a base capability that you should build in for your platform from day one. And obviously, it's like self-interested in me to say that, but I do believe it's true. It's kind of like telling someone if they're like writing Python, or this isn't the best example, but let's say like someone's a Python program. It's like, well, only use classes if your program is going to get big. It's like, no, you should like structure your programming from day one to kind of, even small things become big later. So you might as well kind of make good engineering decisions all the way from front to back. In terms of within the orchestration domain, when Dagster and Dagster Cloud is the wrong choice, I think you're actually seeing a pretty interesting bifurcation in the orchestration domain where, when people are evaluating orchestration from ground up these days, they're kind of generally choosing between three options: Prefect, Astronomer, and Dagster. And I think those three solutions are actually kind of going their separate ways, so to speak, with their most recent directions. So, for example, Prefect has their new Orion project, which is going to be their 2.0 project. And I actually think Orion's quite cool. And it actually makes it a system much more like Temporal, which is a microservices orchestration engine. So Temporal and Orion are, a Prefect, I should say, they're actually more general tools than Dagster. And they're more operationally flexible, but they're much more imperative. So if you need to kind of build a state machine instead of a DAG, you should definitely choose those projects. And they're much less tailored towards the data platform use case. So they have no notion of data assets. You can kind of write almost like a Turing complete state machine using them. But as a result, you can't pre-visualize what the computations are going to be. There's very strict trade-offs there. So if you want something more general and more imperative and something with less operational constraints and therefore more operationally complicated, Temporal Prefect is kind of the way to go. Airflow is kind of your, task-based orchestration system, and that doesn't really think about the full developer workflow. And if you don't think that orchestration should have a fast developer feedback loop, and that's not really what its purpose is, that you should have scripts and tools, and then the orchestrator's only job is to order and schedule them in production, and that's its only domain, then Airflow is a better solution. But for Dagster, it's like if you are building a data platform and need a control plane for it, and you believe that you're bringing this, you should bring kind of software engineering best practices to the data domain, and you want an orchestrator that can be the seat of your full end-to-end lifecycle, then we're kind of the solution for you.
We've touched on this a bit already as far as what you've got planned for the near to medium term future of Dagster and Elemental. I'm just not sure if there is anything else that you wanted to bring up before we start to close out the show.
Oh, there's so many plans and future directions to go. We can save that for the next show. We are, as a company internally and as well for our external communication purposes, we are laser focused on Dagster Day and the 1.0 release and the launching cloud to the world. So those are our plans.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing or find out more about Dagster Day, I'll have you add your preferred contact information to the show notes. And as the final question, what is your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today?
Tobias, you always ask this of tool authors and vendors, and I feel like we're being sucked into a trap because, it's got to be what we're working on.
Well, obviously it's not, because you're already solving that problem.
Yeah, to me, it's a couple things. One, I do think the lack of a cohesive end-to-end developer workflow within the context of data is still a huge problem, an unsolved problem. And I think some of the stuff that we're working on is going to be a linchpin for that, but it's going to be an ecosystem-wide initiative to get that solved. The other thing that comes to mind, and this goes back to this kind of unbundling, bundling conversation, and not to rehash that, but this general notion that we are asking too much of data teams, that they have to assemble like 12 different tools in order to get basic end-to-end capabilities. And I saw a tweet on this, and it's like, if the data ecosystem was in charge of the car industry, there'd be a tire vendor, a steering wheel vendor, a seat vendor, a body vendor, and every single consumer would have to assemble the car by themselves. And that resonated with me. That's why in our platform, we are building in a bunch of capabilities. I call them like a base layer because we're not trying to replace all the products, but we have integrated lineage observability, orchestration, and a basic catalog, so that out of the box, you kind of have like these basic capabilities built in, so that if you only need a simple version of those tools, you don't have to integrate a full another vendor. So to me, it's about the end-to-end developer workflow, and also this notion of like not having to integrate a dozen vendors just to get basic capabilities into your platform.
Well, thank you very much for taking the time today to join me and share some of the recent updates in Dagster and the work that you're doing at Elemental and on Dagster Cloud. It's definitely great to see this commitment to stable APIs and releasing your cloud product as generally available. So definitely excited to see that happen and what comes next. I appreciate all the time and energy that you and your team are putting into building such a quality product. So I thank you again for that and hope you enjoy the rest of your day.
Thanks so much, Tobias. Thanks for having me.
Thank you for listening. Don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest on modern data management, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you learned something or tried out a project from the show, then tell us about it. Email hosts@pythonpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.